Good evening, friends. My name is S. Prashant, Seetha Engineering College, Vizianagaram. Today we will discuss about the small topic of stress strain diagram and mechanical properties. Okay. First of all, stress strain diagram for our ductility material. First, what is the stress? Uh, Stress means the internal resistance force by a body against the deformation is called as stress. Okay, a stress is force by area. Units also Newton per meter scale. Okay, and second one is the strain. Strain means uh, the deformation per unit length caused by the normal force in its direction is called strain. Strain is changing length by original length. Observe the diagram. The strain is indicated the x-axis and stress is indicated the y-axis. Okay, uh, stress equal to indicate the p sigma equal to p by a, and strain is indicated the e delta l by l. Delta l means original length by changing length by original length. It's called strain. Okay, observe the diagram. First of all, B, C. A for proportionality limit, B for elastic limit, C for upper yield point, C dash lower yield point, D equal to ultimate strength, E equal to rupture strength, F equal to mm, actual rupture strength. First, what is proportional limit? Proportional limit, it is the maximum stress at which the stress is proportional to the strain. Above this limit, the plastic deformation of the material occurs. It is nothing but the Hooke's law. First of all, Hooke's law. Hooke's law uh, gives by Sri Robert Hooke in 1678 year, and stress is directly proportional to the strain within the elastic limit. Okay, stress by strain equal to constant. Okay, here a constant is known as a modulus of elasticity. Okay, that is Hooke's law. Next, second point is B point is elastic limit. What is the elastic limit? Even if material is stressed behind the proportional limit, it can regain its original shape and size. Okay, it again original shape and size, that is called as elastic limit. Okay, for example of elastic limit, springs, elastic material also springs. Okay, second one is yield point, yield limit. Yield limit means its stresses applied behind the elastic limit. Behind the elastic limit, B is a elastic limit, and next point is yield limit behind the elastic limit. Then plastic deformation taken place. Okay, for ductility materials are two yielding points. One is upper yielding points. C is upper yielding point. Second one is a lower yielding point. Upper yielding point, uh, unreservable. Okay, it varies with the shape of the specimen, rate of loading. Okay, hence generally not considered as yielding stress. Okay, that's upper yield point. Second one is a lower yield point. Lower yielding stress is reliable one, and hence consider the yielding stress of the mild steel. Okay, this is yielding point. Next one is ultimating strength or ultimating strength or maximum strength. Okay, maximum value of the stress which is applied behind the yielding point. Okay, behind the yielding point is called ultimate strength. Okay, last one is the fracture point or rupture strength. was indicated the E letter. Fracture point, the value of the stresses for the which material starting to fracture or breaking point is called E point. Okay, that's the point, rupture strength. Once you observe the diagram, O, A, B, C, C dash, D, E. This curve indicated the theoretically stress strain diagram for the ductility material, and curve A, O, A, B, C, C dash, D, and F is actual stress strain diagram for ductility material. Okay. Uh, Next, proportional limit, elastic limit, yield point, ultimate point, fracture point. Next one is material properties. Material properties, first of all, elasticity, plasticity, stiffness, ductility, brittleness, malleability, resilience, toughness, creep. All are properties, mechanical property. First of all, elastic limit. Okay, what is the elastic limit? Elastic limit is, it is the property of material by which it can regain its original shape and size when applied load is removed is known as elasticity. Okay. For example, springs and rubber also. Second one is a plasticity. Plasticity means the property which enable the material to regain its original shape and size when applied row is removed is called as a plasticity. Okay, plasticity material. Okay, plastic material also plasticity nature. Next one is a stiffness. For example, this is elastic material. Okay, this is springs. This is a plastic materials, plasticity nature. Okay. Next, stiffness. Third one is a stiffness. Stiffness is ability of material to resist the deformation under the load is called as a stiffness. Okay, ability of material to resist the deformation under the load. Okay. Next one is a ductility. Or ductility means this is a ductility material, and the next one is a brittle materials. Okay, ductility versus a brittleness. First of all, ductility, ability of material to deform under the load conditions is known as a ductility, measured in presence of elongation or reduce the cross section. Okay. uh, this ductility nature is elongation to increase the length and to reduce the cross section area. This type of material is a ductility nature. Okay, this ductility materials, for example, is a mild steel also ductility nature, and gold also ductility nature. Okay, for example, gold also, to apply the load in both sides to elongate the length, to increase the length and decrease the cross section area. That is the ductility materials. And second one is a brittleness. Okay, brittleness means the ability of material to fall without the deformation is called as a brittleness. Or the, for example of a brittleness, brittle material also glass. Okay, e glass less than the 5% of elongation is considered as a brittle material. Okay, that is a brittle nature. Next one is uh, this one is a malleability. Next one is a malleability. What is a malleability means? Property which allow material to deform without the rupture. Okay, is known as a malleability. It is a considered when compressive load is applied. Okay, that is a malleability. Next, fifth one is a resilience. The ability of the to observe the energy within elastic limit is known as a resilience. So observe the diagram. Okay, x-axis indicate the strain and y-axis indicate the x. So observe the diagram and O to y. Y is the elastic point. The area under the curve up to elastic area under the curve in stress strain diagram up to elastic limit is known as a resilience. Okay, in a mathematical definition. Okay, and toughness also same, but toughness also ability of material to absorb the energy without the fracture. Okay, is known as a toughness. Toughness also the total area under the true stress strain curve, which measure the energy observed by the specimen in the process of breaking point. That is known as a toughness. A toughness is mathematically integration of sigma into delta E. Okay, is known as toughness. And last one is a creep. Next property is a creep. The creep is a progressive deformation of the material under the continuous and loading at high temperature is known as a creep. Okay, the diagram time versus strain. Okay, uh, last one is the references. Design machine elements by the VB